Okay, I think we can slowly start. I will first explain anyway what's that webinar about, so more people can join in the meantime. Can someone please raise the hand or write on the chat if you can hear me? Okay, cool. Okay, so officially welcome everybody. You are joining the Rotterdam Cloud Native Talks Service Mesh Edition. So very quickly about that group and about myself. So my name is Dawid Ziolkowski and I work as an engineer at Container Solutions. And this group, Rotterdam Cloud Native Talks, it's supposed to be a typical local meetup group in Rotterdam. As my company operates in Amsterdam and a few other cities, but myself, I live in Rotterdam. That's why I decided to start something here. But I started that group just before the whole COVID crisis started. So I was kind of forced to do the webinar instead. So of course, everyone is free to join. But yeah, the initial idea was to do it locally in Rotterdam. But yeah, anyway, that's the kind of situation. So this is the second meetup for Rotterdam Cloud Native Talks. And this time, as you may know, we're going to talk about ServiceMesh. My idea was that the people who don't know much about ServiceMesh or want to refresh the basics will join for the first part, and people who know the basics and don't want to bother will join later on for the advanced. Of course, you are free to join both as well if you want to refresh basically the basics as well. So yeah, I think we can kick off. So first we're going to talk about the basics of ServiceMesh. We're going to talk about a bit of a history of ServiceMesh and in general what it is. What this talk is not going to be about is how to install ServiceMesh, how to start, how to do basic stuff. And the reason for that is that there are tons of videos on YouTube or even you can follow Istio documentation, because the installation and the first steps are really, really easy. So this you can definitely do it yourself. What I want to do instead is basically help you to understand the concept of ServiceMesh and help you understand few important things about it. Because as you will hear later, ServiceMesh in general is a pretty complicated topic. So it's really the best to understand how it works and what's the point of ServiceMesh in order to make the most of it, basically. So yeah, so we need to, as I said, we need to start from the beginning. We need to talk a bit of we need to talk about the history of ServiceMesh and actually the history of the whole cloud native, and not even cloud native, basically the history of everything. So back in the times, long time ago, we had a situation that everything, like your application, everything you wanted to run basically was running on physical servers, right? So we had to take care of everything from the physical servers to the application level. So we had to first take care about buying the servers, installing them somewhere, then installing operating system on them, then installing anything that that your application needs. If it's Java, then I don't know, Tomcat server. If it's something else, I don't know, Node.js server, whatever. So all the dependencies for the application or runtimes, and only then you could actually install or just deploy your application. Of course, we all understand that that was not ideal. The two biggest issues with that were that, first of all, if something broke, or even if you simply had to upgrade the operating system at some point, it took ages, right? It took like the whole day or something to redeploy everything, because you had to do everything basically from scratch. So you had to, if you need to upgrade the operating system, then of course you need to upgrade the operating system first, which is in itself a long process. And then again, install all the dependencies for the application, only then the application. The second issue was that if you had an application which was for, I don't know, 50% of the time or even 80% of the time not doing much, but for the rest, for the remaining 20%, it needed a lot of RAM and CPU usage was like a crazy, then you still had to have that biggest server, which was basically, yeah, for most of the time not doing anything. So some smart people came with the idea of virtual machines to solve those two problems, right? So with virtual machines, I guess you all also know the idea is that we have some physical server underneath, of course, and later on that could be a cluster of servers. And we don't care, or we don't touch, let's say, we don't touch that often that physical server anymore. So we install it once, we install hypervisor on it, and that's it. We don't touch it. All the rest, so all this deploying application, deploying operating system, installing operating system, deploying application was done on another level, so on virtual machines. So this solved the problem that yeah, if you want to deploy something, you didn't need to anymore redeploy the whole operating system. You don't need to restart the whole server, because yeah, if you had it in virtual machines, then you could spin up a new virtual machine with new operating system version or new application version, and then only then kill the other virtual machine and switch traffic to the new one. So that was one huge upgrade. The other one was the ability to distribute the load a bit better. So if we have a server which doesn't do much for most of the time, we could put some additional virtual machines on it, and yeah, basically switch them depending on the needs. So that was huge improvement, but still, if you think about it, then let's say we have 5 virtual machines on some server, then we have 5 operating system, because in virtual machines we still have operating system, of course, right? So we have 5 operating system which basically are redundant, right? We have operating system on the physical server anyway, so we kind of don't need that operating systems in the virtual machines doubled, let's say. So again, some smart people came with the idea to get rid of that operating system from the virtual machines. So what's left is that, yeah, only our application, right? And that's basically containers, pretty much. So we still have somewhere that physical server. Nowadays, it's pretty much in the cloud somewhere, probably. But instead of virtual machines, when we have, again, the whole operating system and then the runtime for application and then our application, we have only our application and a few small binaries in the kernel in the container to make it run. So that's pretty much, yeah, the next big step. And we end up in the situation that, yeah, we take care only about our application pretty much, right? We don't need to upgrade the operating system periodically, which is a long process. If we want to restart it or do some maintenance, then it takes seconds instead of minutes, because yeah, we don't need to wait again for the operating system to load up. So it's pretty much ideal, right? Well, not really. If you think about it, if you look what's inside that container actually, then you may think, yeah, it's only my application, so it's everything I care about. And we can't strip off anything else from it, right? Yeah, it's our application, so we can't remove some part of it. Well, turns out you can. So if you think about it, imagine that you have some container which is a, I don't know, a front-end application, right? And it has to do some calls to the backend container, to the container with the backend application. So in the code of the front end, you have some line of code which says something like do HTTP call, type post, and send this and this data, right? So that's the thing we care about, right? That's your business logic. You need to do some call, I don't know, to send some form from the user, to send some data from the user to the backend. That's the only thing you care about. But what you actually need to do is a bit more, in some cases much more, because you need to make sure that to retry that call if you have some issues. You need to make sure that this and this is connected. You need to make sure that some specifics are, I don't know, loaded first. You need to write, basically, you need to write quite a lot of code around that HTTP post request, because you basically need to take care more stuff than what you actually care about, more than the pure business logic. And maybe that's not that big of an issue, because we get used to this pretty much in environments where you have pretty well, most of your microservices are written in the same language, right? Because then even if you have to write something something more than you need, then you write it once and then you just apply it to all the containers, right? But kind of the point of microservices is that each team or even each developer can write in its own language, like in the language that he likes the most or he knows the most. So in real world, we have the applications which consist a lot of microservices which are written in different languages. And here comes the issue that imagine a situation that you have, I don't know, 20, 30, 40 microservices which are needed for your application to running. And now, for some reason, for example, because the way of some backend microservice works, you can't do retry in your application. So if you send some data from frontend, if you want to send some data from frontend to backend and eventually save it to database, because the way how backend works, you can't retry that call, because basically it would be written twice to the database, right? There's basically no logic to avoid that. That's pretty common situation. So at some point, you want to change that, of course, right? So you rewrite that backend or you do something to make that retry possible, right? So at some point you deploy a new version of backend or whatever, and you tell all your developers, okay, now we can do retries because it won't be saved twice to the database. Please update your microservices. So we have 40 microservices written in different languages, and they all need to write the same stuff. Simple retry mechanism, but they all have to do in their own ways, because these are all different languages. They all probably use different HTTP libraries for the application, and so on and so on. So stuff that you don't care about, let's say it's not business logic, right? Your business logic is to send that HTTP call, and retry is not the business logic, right? It's the basically networking, just making sure that that call, that business logic you care about, is executed properly. So you need to spend quite a lot of time. A lot of developers need to spend quite a lot of time to update all these different microservices to do that simple task. And here we come to the conclusion. That's exactly what ServiceMesh tries to solve for you. So basically what ServiceMesh wants to do or tries to do is to extract everything which is not business logic from your application to another level, to another layer. So how it works is all these stuff which are related to networking, authentication, everything which is not business logic can be defined in ServiceMesh. And by doing that, if we come back to the example which I just said, if you want to apply that change, so in our example, do retries now, then if you have ServiceMesh, then you do it once with one simple YAML file. You don't care which language microservice is written in, which library it uses. You just define it once and then just instruct the ServiceMesh to do retries for all the applications. That's how it works in general. That's what it do in general, let's say. But how it works is like this. So we have our microservice, our application, which here is service A, service B. And for each microservice, ServiceMesh will deploy a sidecar container. That's the case for most of the service meshes. There are some which works a bit differently, so they deploy proxy container on the nodes instead of on the pods, but most common is basically for each pod. And what that sidecar container do is it hijacks all the traffic coming from your microservice and to your microservice, so basically from your pod and to your pod, and it can manipulate this traffic basically. So if again we come back to that example of retries, so imagine your front-end microservice want to do a call to a bucket, right? So normally it would go basically just from that pod from pod A to pod B directly through the Kubernetes services, of course. But if you have ServiceMesh, then this call would be hijacked by that sidecar proxy, and then that sidecar proxy would send it to a pod of the backend. In the backend pod, the sidecar proxy of the backend would hijack it as well, and only then send it to backend. And by doing that, if we get a 500 from backend or whatever error, normally that backend will of course send back that 500 to the front end, but now that proxy hijacks it again. And if we have the logic, if we instructed the service mesh to do retries, then service mesh will do it for you. So the application won't even, the application won't even know that something happened. This example with retries, of course, yeah, of course, it depends on the specific situation, but the idea was that there can be some issues with networking. So you just lost one packet, or the network got, I don't know, disconnected, restarted, whatever, for 1 second. So this retry mechanism is supposed to solve these kind of issues, right? Of course, it won't, if your backend is dead, not responding or whatever, and it will throw 500 all the time, then of course ServiceMesh won't fix that, right? It's more just for these edge cases. And that was anyway just an example for you to understand how it works and what it does. So yeah, that's the overall idea. And now, how does this sidecar hijacks all the traffic? I didn't mention that. Maybe you know that if you are using ServiceMesh or if you want to implement ServiceMesh, you pretty much don't need to change much in your infrastructure. You don't need to change application. You don't need to instruct application that now it will be running behind ServiceMesh. You don't need to do pretty much anything. But yeah, it's not magic. That sidecar hijacks all the traffic simply by IP tables rules. So if you have a pod, then you have container inside, right? And if you have two containers inside, so you have container of your microservice and sidecar container from ServiceMesh, then these two containers see the same network interfaces, the same localhost, whatever. So if the sidecar container will simply execute some IP tables rule, then it will affect both containers in the same pod. That's why yeah, endpoint sidecar container from the service mesh can just execute, implement few IP tables rules to instruct that pod basically to route all the calls coming from and to the other container, yeah, to route to itself first, and then only it will go somewhere else. So yeah, it's not magic. So just to wrap up, what is this sidecar? Yeah, basically it's a kind of man-in-the-middle component which sits between your microservice and the rest of the cluster. It sits in the same pod that your microservice, and it's being injected to every deployment, to every pod in your cluster. Yeah, it can be automatically injected into your microservice. Can be also injected manually depending on the needs. But pretty much it's yeah, you don't have to do that much, because yeah, you can just install ServiceMesh, implement it. Sidecar container can be injected automatically to each pods, and then yeah, you just instruct ServiceMesh what to do. So yeah, if we pretty much understand, I hope you understand pretty much where did the service mesh come from and yeah, how it works in general, then we may need to answer the question of why would you use that actually, or when, right? So I mentioned that already, that the goal of service mesh is to abstract something that needs to happen in your infrastructure or in your microservices, but it's not crucial, it's not important, or it's not something that you really care about. So basically, yeah, abstract everything which is not pure business logic from the applications, which at the end means that your developers needs to can focus more on business logic, or basically can spend less time on delivering new features, right? Because then they need to, yeah, they only care about yeah, business logic instead of all this extra stuff that normally they need to care about. Another issue is that Kubernetes in general, networking in Kubernetes in general is pretty basic, pretty limited, let's say. Kubernetes can't do that much. Simple example, Kubernetes service is just doing round robin to the containers, right? You can't really steer the traffic and so on and so on. So service mesh meant to gives you much more control over the traffic, and that's why it can also do one of the biggest advantages, let's say, of service mesh, or maybe not the biggest advantage, but the feature that people use the most when they go to service mesh, which is canary deployments. Basically, service mesh, you can instruct service mesh. You have basically total control over the traffic. So you can instruct service mesh to route X% of the traffic there and X% of the traffic there. So canary deployments are easy because if you just deploy a new version of your microservice, then you just tell to service mesh, please route 5% of the traffic to that new application, and then you check how it behaves. If it's all fine, then you can increase to, I don't know, 50% or 80%. And if it's still fine, then you can tell service mesh, okay, route 100% of the traffic to that microservice, and then you kill the other one. What it can also do, it can do really a lot of stuff. I won't mention everything because yeah, we can easily find it in the documentation. There's really quite a lot of stuff it can do, but yeah, you have really a lot of control over the traffic. So we can do stuff like traffic mirroring, which basically means that you deploy 2 containers of the same application, and one container is and when the traffic comes, when the request comes from the client, then this request is being mirrored by service mesh. So it goes to both containers, but only one responds back to the client. So the idea is that you can easily test how it behaves without sending errors back to the clients if they would happen. So that's kind of A/B testing, let's say, but without actually showing the issues to the clients. So yeah, stuff like retries, I just explained. Circuit breaker. So yeah, service mesh can basically take care of killing or not killing, but not sending traffic to the containers which underperform. So you can instruct service mesh to do stuff like, hey, I want all my calls to be responded within X amount of milliseconds. And if that particular container responds longer, then please don't send any more traffic to it because yeah, maybe there's something wrong with it. Yeah, so a lot of small tasks like that service mesh can do. Next big thing for service mesh is encryption. It can encrypt all the traffic within your cluster pretty easily. By pretty easily, I mean, yeah, if you have service mesh implemented, then it's just it's not one easy switch, but it's just a few parameters that you need to add either on installation or just to a few YAML files to encrypt the whole traffic in your cluster. Again, without need to do anything for the microservices. And that's pretty huge deal for a lot of people, because yeah, you don't need to implement this in your application, while still traffic coming out from the application will be encrypted, right? Because that sidecar container sits inside the pod. So no plain text traffic will be anywhere in the cluster pretty much. Traffic-based routing, yes. Again, Sidecar understands the HTTP traffic and few other protocols as well. So it can act based on stuff, or it can even change stuff, change traffic based on the stuff. So yeah, it can understand cookies, it can understand HTTP headers, and so on and so on. So for example, you can easily route the traffic from mobile devices to different version of a microservice, while the rest to different version of a microservice. Or you can route traffic from user X to different microservices and the rest of the users to different microservices. Basically, yeah, and you can implement pretty much any logic based on HTTP headers. And last but not least, unifying network operation for multiple different containers. That's what I was explaining as well. So huge deal for Microsoft, for ServiceMesh, is that the bigger your infrastructure is, the easier it becomes to manage it with ServiceMesh. Simply because, again, if you want to implement new feature, do something new, like, yeah, again, the retry example, it doesn't matter how many containers you have. It doesn't matter in which languages they are written. It's just, you still just need to change one YAML file to implement stuff for all of them. Yeah, so these are pretty much the reasons why you would use ServiceMesh or when. Actually, I didn't talk much about when. So when. Yeah, ServiceMesh is not of course, it's not the gold solution for everybody. It's nice to use ServiceMesh at the beginning. If at the beginning, I mean, if you, for example, moving to cloud, or if you're decoupling your monolith to microservices. So and that's because, again, then you don't need to spend time on writing code in a specific way, right? So you can just focus on decoupling business logic from the monolith to the microservices, while yeah, all the rest of this networking stuff can be taken care like once from ServiceMesh. But here comes also the issue that if you are really moving from, I don't know, on-premise or moving to Kubernetes from typical virtual machines, then learning Kubernetes itself is it's going to be a challenge for you. And then if you put EC on top of that, then you're adding a bit more to that learning stuff. So so yeah, it's also not ideal solution. It's just, yeah, depends how you train your developers, how you basically want to do that. When wouldn't it make that much of a sense to use ServiceMesh? For example, when you have already a lot of microservices and your infrastructure doesn't change, your application doesn't change that much, right? So you have running application. Sometimes, of course, you upgrade some code, but pretty much you don't. You are not on early stage when you add new microservice or drastically change microservices every day. So when your microservices stack is pretty much static, then implementing ServiceMesh, if you have all this stuff already implemented, all this stuff like retries and all that networking logic inside them, then implementing ServiceMesh doesn't make that much of a sense, right? Because you already have that in microservices, and even if you extract it to ServiceMesh, then yeah, it will be easier for you because then you have it in one place. But you basically will spend quite a lot of time on doing that. So you just need to decide yourself if it's worth it. But here comes also another issue, or not issue, another thing to consider, because I covered so far only the ServiceMesh can do from the networking perspective, but it can do other stuff, other stuff too. one of the important thing from ServiceMesh you can get is observability. So by implementing ServiceMesh, you really can get quite nice view of what's happening inside your infrastructure. So especially if you have a lot of different microservices and you don't have that clear overview which talks to where and when and so on, then ServiceMesh can help you quite a lot. Because in case of Istio, you get out of the box Prometheus, Grafana, Jaeger, Zipkin. So tools which can show you, and by show you I mean really show you, like service graph, which microservice talk to which and what data it sends. With Jaeger you get tracing and so on. So if you want to use ServiceMesh, when you and if you should use ServiceMesh, that's really not easy answer to question. Not easy question to answer. Sorry, it really depends quite a lot on your specific case. Okay. So if we get that covered, then we have another issue, which service mesh to use actually. So if you think you could benefit from service mesh, it makes sense for you, then nice, but then you actually need to decide which service mesh to use. Still, a couple of months ago, that decision wasn't that difficult because pretty much Istio was, let's say, the best solution, or everyone was using Istio, and the other service meshes weren't that popular. But that has changed quite drastically over the last few weeks, last few months. Linkerd, when Linkerd released version 2 of its service mesh, it was basically written from scratch. And it differs quite a lot from version 1, and it's also number 2. It's still number 2 now for a lot of people, but it's getting a lot of attention. There are, as far as I checked, there are 33 service meshes now on the market, which is crazy because myself I thought there were like 5 or 6 of them, but apparently there are 33. But pretty much still most of the people talk about Istio, Linkerd, Kuma, and there is another one which I forgot the name now. But still, the decision between these is in theory simple, but in practice is not. So we have Istio, which is of course the most known. It has the most features. That's why it's represented by this chart here. But the problem is that a lot of people, a lot of companies still don't really know if they want to actually implement service mesh, or don't really still understand the whole idea of service mesh. So they want to just to test it, or they are using just few features of service mesh, not everything it can do basically. So then using Istio, well, sure, you can do this, but if you really plan to only use few stuff that it can do, like if you only care about encryption of the traffic and not that much about all the retry circuit breaker stuff, then maybe you don't need Istio, because yeah, it does much more than that. Then we have Linkerd, which, as I said, it's in version 2. It's pretty great service mesh. It does unfortunately lack some features in comparison to Istio. Some of them maybe for some companies, these lacking features maybe not a big deal. So then it's perfect for you, because Linkerd is lighter, more lightweight than Istio. It's basically simpler and lightweight basically. So it's a really great one to start with if you're not really planning to use all of the features, or all of the stuff that service mesh can do. Then we have other service meshes like Kuma. I have to admit that this representation, this picture I used, is not that fair anymore. And also, I didn't mean by then that Kuma is nothing interesting. The idea behind that picture was that Kuma was nice service mesh, but it didn't do that much for you, like out of the box, as the other service meshes do. And that was very good for people who, I don't know, more advanced people maybe, who are really aware about what they want and what's inside their infrastructure. So they really could make Kuma kind of very tailored service mesh for them, because you could basically define yourself how it's supposed to work, what it's supposed to do, and so on and so on. So we didn't get that much overhead. And yeah, I would say it's for more advanced people maybe. But also a recent version of Kuma, they implemented quite a lot as well. Like Kuma at the beginning, when I created the site as well, it didn't have UI at all. Now it does. So yeah, it's also evolving. So yeah, that's again what I was briefly talking about. Istio has the most features. Let's put it that way. So you really need to, before like going, yeah, let's try Istio, let's try Linkerd, whatever. It would be better to just sit down and think what you really want from Service Mesh and what is important for you. Because as I said, there are some features missing in Linkerd, but maybe you don't need them. And then Linkerd can be better than Istio for you, maybe because it's easier, lighter, let's say. But there are some, I'm talking about missing features. One of the missing feature for myself is that Linkerd still can't see the HTTPS traffic. So if your application does any HTTPS call anywhere, then Linkerd won't see it. So you don't see it in observability tools from Linkerd and so on and so on. So even if your application does a call to, I don't know, GitHub or some Docker registry, whatever, then you won't see it in Linkerd. These kind of missing bits, for some maybe not that important, but for some maybe important. So yeah, Istio definitely can do more, but again, maybe you don't need everything that it offers. Also, Istio was pretty, I shouldn't say it was pretty heavy, but it was definitely heavier than Linkerd. When you installed Istio back then, it deployed few containers to your cluster. It deployed quite a lot CRDs. It deployed 3 different tools, like extra tools, except itself. So it deployed Prometheus, Grafana, Jaeger, Zipkin. Now it also does Kiali, and so on and so on. So basically, it deployed quite a lot of stuff. Linkerd deployed just itself and its UI. But the reason I'm talking about this is that in version 1.5 of Istio, that has changed. Istio now consolidated into one single binary instead of few components. So now it's pretty much aligned with Linkerd. It doesn't do that much. I used to hear often from people, some people that were interested in Istio, that I would try that, but it's pretty heavy and installs a lot of stuff. So it's not the case anymore. So worth to try the 1.5 version. So yeah, decision which service mesh. Again, it's it's not that straightforward, and you just need to decide which one would suit you the most based on what's the most important for you. Some service meshes can't run anywhere else than Kubernetes. Some service mesh can run on-premise as well on normal virtual machines. So if that's your requirement, then already the decision is easier for you. Let's move on. Now, it differs from service mesh to service mesh, but most of them works in a way that they deploy some components, right? So Istio deploy itself, Istio the binary to the cluster, Linkerd deploys itself, and so on and so on. So basically, we have some components when you install service mesh. So what it means actually to install service mesh or implement service mesh basically means that you need to install it like pretty much any other tool you install in Kubernetes. So you download some installation script or do it through Helm, or now with Istio you can do it through operator and so on and so on. So basically you install it somehow, and then it deploys some components on your cluster. And then these sidecar containers, which we talked about, are being injected into your pods. And then you basically define everything with YAML files, like anything else on Kubernetes. So here, I will give you just a few examples from Istio, just to give you the idea what it means to work with Istio. With Linkerd, it would be pretty similar. It would just, of course, just use different resources. So in case of Istio, if we want to, in case of Istio, there are a few custom resource definitions which are the most important for you, and you basically need to apply some to make the traffic working in your cluster. So we definitely need a gateway which acts as an ingress for Istio, and we need some virtual service definitions, which I'm going to talk about in a sec. But overall, again, the overall idea is that you just define some YAML file which basically instructs ServiceMesh what to do. So in the example here, we will now instruct Istio to implement or deploy basically the gateway, which would basically act as an ingress, right? So we have some simple YAML definition when we define what is our domain, on which port should listen, and so on and so on. And we just deploy it like any other stuff on Kubernetes. So, right, either via kubectl apply or with some CI/CD or any tool you use. And then, of course, you can work with these components like any other stuff on Kubernetes. So again, you can use kubectl get or kubectl describe to interact or to check how it works. Again, virtual service is another building block, let's say, from Istio, which you may use in case of Istio. Virtual service is basically the definition of the logic how the traffic is supposed to be routed. It does not replace Kubernetes service. It's more like it acts on top of it. So, for example, I mentioned earlier that with ServiceMesh you can do easy canary deployments, because you can tell to ServiceMesh, please send 10% of traffic to this and this microservice, and that's exactly what you would do here in the virtual service definition. So you need to deploy virtual service for each service in your cluster, for every microservice in your cluster, to make it work properly in ServiceMesh. Maybe it sounds like a lot of work, but it is pretty easy, because you can just template it basically. But the point is that on the initial steps, when you're just starting with ServiceMesh, so first you need to deploy some gateway to have a way to route traffic from the outside of the cluster to inside. And then you deploy these virtual service definitions to all the microservices to basically instruct Istio to route the traffic between microservices. And now, if at some point you would decide to implement something new, like let's go back to that retry example. So at some point, if you want to implement retries for failed calls, then you would just do kubectl edit virtual service and the name of virtual service, which in this case is bookinfo, right? And then just add a few more lines to this YAML definition, which would be like, which would be basically instruct Istio to route only X amount of % traffic to this. And then that's it. Just edit this virtual service and Istio do it for you. So that's pretty much in general how working with ServiceMesh, with Istio and with other service meshes works. You deploy it, of course, like install it on your cluster. As I mentioned, deploy some
some containers in your cluster, and then you just with YAML definitions you instructed what to do. Yeah, here is another example that you can inject, for example, 5 fault injection, right? Basically, so you can instruct ServiceMesh that if you have a call from front end to back end, then backend will respond 10% of the calls. Backend will respond with HTTP status 500. That's a pretty nice feature to test how your application behaves, because especially in big infrastructure, big microservices stacks, if you have, I don't know, 40 microservices and they all and every call from the client needs to touch quite a lot of them, then maybe it's not that easy to understand where does the error come from, or is this component causing the issue or the other. So with this simple feature of ServiceMesh, obviously in this case, you can inject the 500s to some microservices, and then you will see if the other microservice, so in this case the front end, let's say, if it can handle these errors properly, if it will crash, like the whole application will crash, or it will just do some logic to retry it or whatever. So basically the idea is that you can test the issues yourself instead of testing with clients. So these were just 3 examples of custom resource definitions from Istio. There are 21 of them, as far as I remember correctly. But basically, these are three the most used that you will touch the most. Maybe not fault injection, but destination rule. But the overall idea is that no matter which service mesh you choose, then usually the work will look like that. So you need to learn basically all the resources from the specific service mesh and what they do, and then you just deploy them, edit them, and so on and so on. So to wrap up again, ServiceMesh is installing. First you install ServiceMesh. It will install some components of itself on your cluster. Then it will take care of injecting the sidecar containers into every pod, every deployment you do, which will hijack all the traffic to and from that application. And then you basically work with YAML configuration to instruct ServiceMesh what to do, where to do, how to route the traffic, and so on and so on. And we do all of that to basically extend Kubernetes, or to overcome Kubernetes networking limitations. And that's pretty much for the basics of ServiceMesh. Any questions so far? Yes, exactly. There's Kiali UI in Istio now, which can do pretty nice graph. Basically, we'll just show you how the traffic goes between microservices in your cluster. Yes, we do record that. I will share that afterwards as well. Okay, if no more questions so far, then I will move on to a bit more advanced stuff. Okay, so a bit more advanced stuff. Well, this talk is gonna be similar like the first one, so I'm not gonna tell how to install something, how to do whatever. Basically, I want to cover stuff which you can easily find in Istio documentation, basically, or just follow the simple tutorial from YouTube. What I would like to talk to you about is more deep dive stuff from how it works, because you may already be using ServiceMesh for a while. You know how it works, but you may not know how it works really. I mean, you know it hijacks traffic, but how exactly it hijacks traffic and so on and so on. I will cover also some common issues. Common issues, basically stuff that you may care about on day 2 with ServiceMesh, or more like month 6, because it takes a while to implement ServiceMesh. So let's go back to the sidecar. I was talking about sidecar container. So what really is that sidecar container? Well, it's an Envoy. I guess a lot of you know Envoy. It's not like Istio or Linkerd or whatever. They have specific sidecars to themselves. Most of them are using Envoy, not all, of course. Most of them are using Envoy, which is basically C++ based reverse proxy, and it's nice that they do that because it has it's proven technology. It's very low performance overhead, and it's been proven to work nicely on huge clusters. And when I say low performance overhead, that's what Istio says that what it means. So single Envoy proxy, so single sidecar container will use 0.5 vCPU and 50 megabytes of memory per thousands requests per second going through that proxy. Then Istio telemetry, that's extra component. It's not related to the sidecar at this point. And as you may see at the bottom, the Envoy proxy adds 6.3 milliseconds to the 19th percentile latency for your traffic. So I wonder if you think it's a lot or it's not a lot. For most people, it won't be a lot. For some people who really count every microservice milliseconds, that may be quite a lot, especially that it's for single sidecar, right? So if you have call which touches 3 microservices, then it will be extra 18 milliseconds. So yeah. I wonder, what do you think? But that's the old information. That's for all the folks that uses older versions of Istio. In new version of Istio, the situation looks like this. In version 1.5.4, it only adds 2.8 milliseconds instead of 6.3 it was, I think. So that's quite of achievement. And the guys from Envoy and from Istio, all of them actually, they are working hard to make that even lower. If that's impressive, then I'll tell you that this 2.8 milliseconds is with NTLS enabled, which means with a whole traffic in your cluster encrypted. So that's something. Although that's the results from HTTP 1.1 benchmarks, which is a bit surprising, but yeah. Anyway, even if HTTP 2, it's not much more. So if you think that it's too much for you, too much latency or too much performance overhead or whatever, then you as an advanced user should take a look about Cilium. Should take a look at Cilium. Basically, Cilium is it's not the point of this talk, but I'll quickly tell you. Cilium is another tool which implements. Basically, it changes quite a lot how your Kubernetes cluster works. In using eBPF, it can replace completely kube proxy, which means your Kubernetes will no longer use IP tables rules for all the traffic management, because especially in big clusters, that the IP tables is one of the biggest performance degradator in Kubernetes, let's say. And Cilium solves that by using eBPF. But yeah, I just point you to cilium.io, and you can read about Cilium itself there, because it's quite a huge topic on its own. So let me just tell you that ServiceMesh without Cilium works like this. So you have a microservice, right? In the pod you have some container, and to do this hijacking,
that sidecar container from the service mesh. That sidecar container, I mentioned that it applies quite a lot of IP rules to forward the traffic through itself, basically, right? To hijack the traffic. So how it works is that if the call is leaving the container, it has to go through the whole TCP/IP stack to hit the loopback interface, and then it has to go through the whole stack again, TCP/IP stack again, to hit the sidecar container, and then it has to hit the TCP/IP stack again to go outside. So yeah, that's the normal situation. If you have, of course, if you have, that's not that big of an issue for the, well, it only adds you a bit of an overhead when creating new connections, new TCP/IP connections, right? When you have already when you have a connection already created, then it's a bit easier. But still, it's not really optimal, let's say. With Cilium, on the other hand, it looks like this. So as I mentioned, Cilium can replace kubeproxy in total. So Kubernetes will no longer use the IP tables to route the traffic, let's say. And Cilium itself is also can also manage your traffic a bit differently than the pure Kubernetes does. So it can basically get rid of this extra TCP/IP stack going through the whole TCP/IP stack twice. So it gives quite a bit of a performance increase. So yeah, that's something for you folks who are already looking for the small latency numbers and so on and so on. Now let's discuss a bit how this how again this IP tables rules routing thingy works. So from the Linux kernel perspective, there is no such thing as a container, right? So nowhere in the code of Linux kernel you will find a definition. Hey, that's how container works. Blah 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 blah. For Linux kernel, the process running inside the container doesn't differ from the process running on the virtual machine itself, right? So if you have let's say Nginx running on the machine and you have Nginx running inside the Docker container, for the kernel is pretty much the same. The only difference is that kernel applies namespace isolation to the process which is supposed to run as a container, right? So if we have normal Nginx, then it just runs as a process. If we have process Nginx in the Docker container, then Linux kernel will make sure to package it into the namespaces. Basically, it's just the isolation mechanism. Isolation mechanism which Linux kernel gives you. So if you have two containers, and then they all will look like, then they both will look like looks like this. So they will have they will have different mount points, then they will have different host names, they will have different PID handling. So if this container will send a kill signal, then this container won't see it. They will have different users. Basically, everything will be separated, right? Yeah, that's in general how Docker containers works. But in case of the pod, in Kubernetes pod, it's a bit differently. So what Kubernetes pod is similar situation. We have these namespace isolations applied to the processes, but two containers in one pod will share some namespaces. So in this situation, again, this Nginx and this Nginx, they will see themselves basically as running on completely different machines, on different virtual machines or physical machines. Basically, from their perspective, that's different machine. While in this situation, this Nginx container and this logger container will see themselves as running on the same machine. So as you can see, still something is separated, right? Mount namespace and UTS namespace, which means that, yeah, of course, this container will see its host name as different as that one, and so on and so on. But all the rest are shared. And as you can see, the last one is network namespace. And these two containers are in the same network namespace. So all the containers in one pod are in the same network namespace, which means they see the same network interfaces, which means basically from their perspective, yeah, they are touching the same network interfaces. So if that Nginx will bind to port 80 on a local host, then this logger won't allow, or if we would have second Nginx here, let's say, that's the better example. If you would have second Nginx here, and he would also try to bind port 80 on localhost, he wouldn't be able because that Nginx is already occupying the port. And what it also means is that if this logger, since that's the same network, so if this logger container will do IP tables block port 80, then it means no traffic on port 80 will hit the logger container, but it also won't hit the Nginx container because it's being applied to the same network namespace, right? So to the same network eventually. So basically, that's how Sidecar container from ServiceMesh can hijack all the traffic, because it can just apply the rules to route everything. If anything comes on the, I don't know, all ports or whatever, then please send it to me, right? So that's simple mechanism that Sidecar is using. So it's not some IRP tables magic. It's just using what a Kubernetes pod allows you to do. Okay, so that's pretty much about some more details about how ServiceMesh works. Now let's talk about what you may find annoying. I give you the examples from Istio because I have the most experience with it. So one and the most important tip I can give you is please use Istio 0.1 because I mentioned that earlier already that in older versions, in versions lower than 1.5, Istio had few components which all were deployed into Istio namespace, specific namespace. But the point is that there was quite a lot of different components which creates the whole Istio itself. In version 1.1, they basically consolidated this into one single binary. And it's super important because ServiceMesh in general, and Istio as well, in general, they are quite complicated solutions, right? ServiceMesh itself is kind of like Kubernetes, right? So its whole system, it has a lot of moving components, and a lot of components can break. So the problem was that when something broke in Istio, or something wasn't working properly with Istio, it wasn't really that clear where to start finding the issues. If also, because it's super easy to install ServiceMesh, and it's super easy to move your microservices to ServiceMesh, to Istio in this example, then you don't really need to learn you don't need to really learn that much about Istio to make it work, to make your infrastructure work with ServiceMesh. You just need to install Istio, which is super easy. Then you just need to deploy this gateway definition and a few virtual services definition. You are good to go. The problem is that if something breaks, then there are a lot of different components, and you don't know which one does what. So you can start googling start googling, or basically start reading in the documentation. But overall, it's quite a lot of learning to understand where to find the issues for this specific issue, where to start looking for. And that has greatly improved in 1.5, because since it's single binary now, then it's super easy to do so, because then you just check the logs of that single component, and that's it. What they did is they basically put all of these components into this binary, so it's not rewritten into now that one microservice does everything. It's consolidated into one container. So it's still kind of the same. You need to go through the same process of debugging, because you still have the same different logs from different components.
but you have them in one single place, which makes it much easier to basically to read, right? You can just scroll up and see when the issue started, and then you check in the logs which component caused it first, and so on and so on. So that's one of the most important, I would say, part if you want to start with Istio, or if you have issues with Istio. Now, I will go through a lot of quite few examples, pretty random examples of stuff that may cause the issues at the beginning, or make even if you're pretty more advanced. These are without specific order. These are just most the one that can be seen the most. Usually when there is something wrong, traffic is not hitting the microservice, or basically it's not hitting as it's supposed to, you have two things to do. So first of all, I just mentioned, just check the logs of Istio daemon, which usually runs in Istio namespace. And the second thing is just run the logs of Istio sidecar container, so Istio proxy for the specific pod deployment. The distinction between the two is that depending on the issue, if there is issue which hits pretty much the whole cluster, right? So you implemented, I don't know, retry mechanism, and retry mechanism doesn't work for all the microservices, then you pretty much would rather check it in Istio daemon. But if there is an issue with one specific container or one specific deployment, then you would rather, of course, check it with for the sidecar of that specific deployment. And now, if you check the logs of that Istio proxy container, then in each line you see the HTTP code of the response, and after the code you will find the flag, envoy response flag, which looks like this, and R, UO, UF, and so on and so on. And these, a lot of people ignore them because it looks like just some random letters, but these are actually telling you exactly what's wrong. So you can just find in Google the list of all the envoy flags. These are the most common you can find. So as you can see, for example, if you see line in the Istio proxy saying that we have 500 here or 403 here, and after that you see an error, then it means that Istio couldn't find or envoy couldn't find the route. So you need to check if the destination rule or virtual service is has been applied, or it is applied properly. If you see example, if you see UO, then it means that Istio killed it because of the circuit breaking mechanism. So these are just few examples, but the point is that these flags are pretty important and can help you find an issue pretty quickly. Another common thing I see is that people apply some rule and then they and then basically they think it doesn't work. So let's say we have a rule, that 50% of the traffic goes to microservice version 1 and 50% goes to microservice version 2. And now you want to change that to, let's say, 10% and 90%. Doesn't matter how much. Basically, you want to change that. So what you do, you just do kubectl edit virtual service, and then put the name of virtual service. And then you change one line in that YAML file, which basically change 50 to 40 or to 10 to whatever. Then you save that edit, and you refresh the microservices, refresh the website or whatever they do, and you see that nothing has changed. You refresh a few more times, and you see that nothing has changed. So then people start panicking, and they revert the change, or they start googling what's wrong, why it doesn't do anything. And usually the solution for that is just wait. The thing is that it takes a while for Envoys to pick up the configuration, and that's for two reasons. First of all, Envoys wants to make sure that they don't kill existing traffic, right? So they will wait first for the open session to close, only then to apply the change. And second thing is that's especially on huge clusters or big clusters, Istio tries to make sure that all the changes are implemented at the same time. So when you do some change, but that happens only if you implement something on cluster level. If you implement some change, then Istio will send that configuration to all the envoys, and then it will wait for the confirmation from all envoys that they received the config with this in this specific hash, so the specific version, and only then it will ping them again to actually apply that configuration. So if you have, I don't know, hundreds of services, then actually it may take, yeah, like, I don't know, 1 to 3 minutes to apply that change. So yeah, so that's surprisingly, that's pretty common issue, or not issue, just lack of patience, I would say. Yeah, some other thing to keep in mind. I mentioned at the beginning that you don't need to change that much to start with ServiceMesh. You don't need to change the application code usually, but there are some things that you need to change. Depending how your infrastructure looks like and how many microservices you have and how different they are, let's say, if all of your microservices are simple HTTP stuff, then probably you won't hit any issue. But if you have some encryption, maybe in one namespace, if you have some database, you have some TCP traffic and web sockets, basically the more not standard stuff you have, the more likely that you will hit an issue. And usually these issues can be solved by doing what Istio asks you to do in the first place. So there are a few requirements to run Istio, and these are as follows. So service association. A pod must belong to at least one Kubernetes service, even if it doesn't expose any port. That's something that you normally don't do, right? So it's easy to miss, but basically, yeah, it's just requirements for Istio. If you don't do that, so if you have some pods which doesn't have services and you will try to call them directly via IP address or whatever, then it should still work, but yeah, Istio won't see that traffic, or you may find some weird issues. Or if you will try to treat them like any other application, then yeah, you will have issues. Application UIDs. I talked about Linux kernel namespaces, and then you could see that 2 containers in one pod share the same UID namespace, which means that they can't have the user. Two users in 2 containers can't have the same UID. And since Istio Sidecar container uses UID of 1337, which means that any other application, or any other container in the same pod can't use that 1337 UID. So your user, basically, which runs the application in your container, can't be user of UID 1337. Istio picked 1337 because they, I don't know if they assumed or if they checked, but the point was that no one usually uses 1337 for anything specific, so that should be the less problem causing UID. But yeah, you just need to keep that in mind. Another stuff, a lot of clusters have pod security policies. If your cluster does, then you need to make sure that netadmin and netrow capabilities are allowed for Istio. Yeah, if you are using Istio as a CNI plugin, because there's I didn't talk about that, but there are 2 versions of two possibilities of installing Istio, 2 ways of installing Istio. Say one of them is installing Istio as a CNI plugin. If you do that, which is recommended, by the way, then you don't need to do that. Deployments with apps and version labels. That's also which, since it's not mandatory in Kubernetes, then quite a lot of people don't do that. It's a good practice in general, but yeah, still not all the people do that. But in Istio, well, you don't need to do that. It's not a hard requirement, but you should, basically, because if you don't, then you will lose quite some metrics and telemetry, which Istio can do it nicely for you. Some other thing, name service port. So I mentioned also earlier that Istio can understand envoys, so Sidecar can understand the HTTP traffic, so we can route the traffic based on HTTP headers or cookies or whatever. And Sidecar can understand also not only HTTP but also a few other protocols. I think there are 6 of them. It can understand Redis, I think Kafka, basically few protocols. And for that to work, you should name service port in a specific way for Istio. So basically, you should put protocol minus suffix, so protocol minus something. So, for example, HTTP minus my service X. By doing that, you basically instruct Istio. You tell Istio what traffic will be here, so it's easier for it to pick it up. By default, automatically Istio can detect HTTP and HTTP2 traffic. So it will. So if you only have these, then you don't need to do that specifically. But if you have some Redises and some other protocols running around, then you should name them, because if you don't, basically, then everything still works fine. But Istio won't be able to do layer 7 stuff. So yeah, you will lose some features. Some other stuff. If you running a cluster which is pretty highly secured, let's say, and your firewall by default blocks everything except what you define, then you need to be aware that you need to open 23 different ports for Istio to work properly. I didn't mention them because that's quite a long list. You can easily go to Istio documentation, and then there's a nice list of which ports needs to be open. Some other common stuff and easy, common stuff, which in theory is easy to find if you know that's the thing. So you may run into the situation that you apply some rules and you get some HTTP errors, and you can't find the issue in Istio logs. Well, then one of them specific is very specific one. So if you have a microservice for which you applied virtual service definition, and then you apply a destination rule on top of that. I didn't talk about destination rules before, but we are now in advanced part of Istio, so I guess you know what it is. So if you apply destination rule and just after that you're starting getting 503, and they disappear if you remove that destination rule, and you double check that this destination rule, that the YAML is properly defined and everything should be fine, then it's probably TLS issue. So what you essentially need to do, what you essentially need to do to make sure that you're inside the destination rule definition, your traffic policy matches your global server configuration. So you are running MTLS in one of 3 modes on Istio, so it needs to basically match with what's inside the destination rule. Another funny issue, actually, which is really funny, but really annoying sometimes. You may end up in the situation that every 45 seconds, your TCP connections will be killed, basically, and that happens only when you are using MTLS. So if you have some microservice which keeps the TCP connection for quite a lot of time, or it normally uses one connection, like let's say, I don't know, indefinitely to send some data, then you will get that issue that every 45 seconds any connection from your microservice will be dropped. And that's because Istio is restarting every 45 days. That's a typo, sorry. It restarts every 45 days to refresh certificates, and pretty much can't do anything about it. So the only thing is to either change your application to handle that. So to make new connection on drop or whatever, or not use MTLS if you wish. Another issue, sidecar crashing and load. That happens sometimes, and it happens basically usually it happens because open file descriptor limit is by default set to 1024. Quite a lot of system, quite some clouds as well. So for that very simple issue is to raise the limit, raise the limit. The problem is that it's not that easy to find that actually that's the issue, because you won't see in the logs, you won't see in the logs message that, hey, I crashed because it's a file descriptor limit. So yeah, it's not that easy to find that this is a specific issue, but if you know that it can happen, then you should always just check up front. Another issue, I have to admit that I'm not sure if that's the case anymore, but there was an issue that if you had an Nginx running as a reverse proxy for a microservice, so you have some container and there was some application running and you had Nginx in front of it, which by the way you shouldn't do, right? But that's another story. But if you have, then it wouldn't work with Istio. Wouldn't work with Istio basically. So the traffic would be not hitting the application. And that's because Envoy requires minimum HTTP 1.1 protocol. And by default, if you run Nginx in reverse proxy mode, it will use 1.0. And again, I'm not entirely sure if that's still the case, but not everybody updates stuff to latest version. So you may find yourself in that situation. Okay. Last issue. So this is one of the issues that I hated myself the most. It took me a while really to figure out what the problem was. So it's pretty common that you have few different virtual service definition for one Kubernetes service, for one microservice, right? And that's because some people like to split different features, let's say, to different virtual services. Because in general, you have virtual service definition, you need to have one for each microservice, right? To instruct Istio basically to run the traffic. And if that virtual service is supposed to also receive the traffic from the outside, so from the internet, then in your virtual service definition, you will see, you will basically point to which gateway to use. And that's the typical virtual service definition. So we say, please use this gateway for incoming traffic, and then match the traffic based on the URL, and then send it to this and this specific service in my cluster. So yeah, that's the normal typical definition, minimal definition which you need for your cluster. And then if you don't like having everything in one YAML file, then you may deploy second virtual definition, which will be only responsible for routing the traffic to a specific subset of containers. So which means basically to specific version of container. So you may use it either for canary releases, right? So you deploy V1 and V2, or you may use, I don't know, V1 for the mobile clients and V2 for desktop clients. Anyway, the point is that it's pretty common to use that structure, right? So we have one basic virtual service definition for the application, and then other virtual service definitions, which each of one do something specific. So it's easier to then to change the configuration or revert it, let's say. So if you want to revert something specific, imagine that, for example, we inject that fault injection thingy that I showed before. For that, if you would have one big virtual service definition, then you would have to go through it, search when is that defined, and make sure to only remove these specific lines for fault injection. On the other hand, if you have this separated, then you know that you just need to delete kubectl delete virtual service fault injection for service X. Not at YAML. That's it. So the point is that it's normal to have different virtual services for the same service. Now, the problem is that this causes the issue that traffic which comes from the outside world, so from the internet, will hit only one virtual service. Will only hit the one which has defined gateway in it. So if this example, if we have another virtual definition which splits the traffic between mobile and desktop clients. So let's say, by the way, that's only small part of the virtual service definition, right? So this virtual service definition splits the traffic, and you want to split that traffic also for the clients coming from the internet, actually mainly for them, then it wouldn't work. So you deploy that virtual service, you double check the syntax, everything seems fine, but yeah, it doesn't work. It simply doesn't work because the call will only hit the one virtual service which has gateway defined if it's coming from the outside. So the solution for that is simply to include the same stuff, so the same subset definition into your virtual definition, or to say it more generally, anything that you want to apply for the traffic coming from the outside needs to be applied in this one specific gateway. This one specific virtual service, which also has a gateway defined. Yeah. Okay, we came to an end. That, as I said, these were only a few examples, but most common stuff that I see people struggle with Istio. I hope you learned something. Let me see if there are some questions. If there are some questions, please ask them now. Yeah, so 2.8 milliseconds was without Cilium. That's improvement in Istio 1.5.4 without Cilium. Yeah. Yeah. Yeah, the thing with ServiceMesh is pretty much like with Kubernetes in general. So it's so maybe not so complex, but it gives you a lot of features, a lot of stuff you can do with it. But a lot of people do only basic stuff. So the same like with Kubernetes, right? You can only use it for deploying pods and that's it. But you can also use it for using Kubernetes secrets, using Kubernetes I don't know, disk, whatever. My point is that there are a lot of stuff that ServiceMesh can do, and it's pretty much only up to you or your imagination how to use it. Yeah, how difficult is to debug is it compared to Linkerd? Now with 1.5. Now with 1.5 versus version from Istio, it's pretty much the same. Before it was a bit more difficult. As I said, yeah, you had to know which components to check the logs, and it wasn't that clear that even if you found an issue in one of the components, then you couldn't be sure that actually that component caused the issue, or it showed you that issue because other component failed. So it was a pretty tough to learn all the insights of the Istio. Now with 1.5, yeah, as I said, it's super easy. Okay, any other question? Yes, the previous meetup was about Cilium. I was actually explaining that, but unfortunately we don't have a recording because I forgot to press that button. Sorry. But also the previous meetup was very general. I was just explaining Cilium, the theory of Cilium and how it works, because it's also a pretty huge topic. So it's not that easy to explain everything in 45 minutes. So that meetup was pretty much theory. I didn't show that much, but I am planning to do a next one, pretty much about how to actually use it and what it does. So there will be next one about Cilium. Okay, thank to all of you. There was my email at the beginning. If you saved it, feel free to ask me anything. Let's stay in touch and hope to see you on the next meetup. Thank you very much.